Hello, I'm MC Toon, the worst rapper in the world. Welcome to the channel here. Today, I've got a debate with Bev, who goes by Try Thinking on Twitter. This is going to be hosted on a Discord server run by Emma UK, and we've been setting this up a little bit. Had a couple issues. He's trying to go live in Discord so I can see his stuff, but it's not been working. So we got a couple ideas for how to fix that. But otherwise, what I'm going to do is I'm going to switch over to their stream, and we'll get going here in just a second.
Or the horizon rose to eye level, which I initially said no, doesn't work. So,
Hang on a minute, Beth.
I'm here if you guys are ready.
Yep, give me a second because it doesn't look like my OBS is picking up the sound.
picking up anyone's sound or
all technical issues that can go wrong will go wrong, apparently.
have you got anyone checking the stream? No sound on YouTube.
Yeah, give me a second. Let me just go through sound. Don't know what's changed. Nothing.
Oh, is it your thingy account's got the same problem that you had this morning? Then has your streaming account got the sound bug?
I'm not entirely sure. Okay. Might be OBS. There we go. Shut OBS down. Restart.
So yeah,
Okay.
they are.
Can anybody hear me now?
They are trying to figure things out on their server, and I've got their volume down quite a bit. You can still hear them talking a little bit in the background. I'm muted, and yeah. So they're still sorting out some problems on their server, but I think they've got it now.
We won't bother with that. We've got Bev with McTunes this evening. Discussion, debate. We've set out the format, which is probably very similar to all the others. We're going to do 10-minute presentation from each, 5-minute rebuttal, uninterrupted, and then we're going to go on to 20 to 30 minutes of backwards and forwards between the two, and then we'll go on to questions. So we've already decided, I think, that McTunes is going to go first. So are you ready?
I am. So let's
awesome.
see.
And yeah, thanks for joining us. Take it away.
Yeah. All right. Well, we heard just a brief thing from Bev talking about the horizon rising to eye level or not. So I'm going to put in here the link to what I'm talking about here. So this is, if you see that there, Bev, this is an observation by Jesse Kozlowski, a licensed geodetic surveyor. This was in, this is the Cape May Lighthouse from across the Delaware Bay at Broadkill Beach in Delaware. He took it in just about 3 years ago, May 3 of 2017, and he's got the telescope on his theodolite leveled, so you can see going across the screen there the eye level, and then you can see the lighthouse is goes right across the lighthouse there. The eye level, right near the top where the light of the lighthouse is, And the lighthouse is 154 feet, and the elevation of the theodolite is 20 feet. So as you can see there, and it's leveled, right? So it's going 90 degrees from zenith, and so the elevation of the lighthouse is 154 feet. Obviously, the bottom of the lighthouse has to be below where sea level is, according to where Jesse has set up his theodolite. So don't know what could cause that other than a nice curve of the earth. So all right, and then he has another similar one. It's nothing if you can't repeat it, right? So he has another one I will pull up. He has a bunch of them, but I'm picking just a couple. I'm not going to do a ton. Let's see, copy image address. So there is the second one. This is viewing Atlantic City from Wildwood, New Jersey. So December of 2018. Same thing. He's got a Trimble 1 second S7 total station setup levels. So the vertical angle is 0. The horizontal then is right on the crosshairs. And you can see again that he is at, his height is 16.84 feet. The top of the building there is 616.4 feet. Now, he himself, as a surveyor, went and surveyed the actual height of all the corners of that building, which he has elsewhere on his website. If anybody is interested, you can look at his website. I'll put the link to his website in my chat, and you can see in Emma in your chat that's just jessekozlowski.wordpress.com. I'll drop that in there as well. So he's got details on his surveying. So same thing here. We have horizontal, and the horizon doesn't rise. In fact, we're sighting off the corner of a building that we know is 616 feet high. So if he is physically at 16 feet above sea level and looking across somewhere 31.88 miles away, he is there's something causing the building to be lower. Now, when we consider the effects of refraction, because refraction is an issue, we can't ignore that. It's not a, let me make sure I'm getting the right thing here. The effects of refraction have been quantified, and I will grab just one publication and give it to you here. It's it's a bit of a long name. It's called Monitoring the Refraction Coefficient in the Lower Atmosphere Using a Controlled Setup of Simultaneous Reciprocal Vertical Angle Measurements. So to do that, they use two theodolites. They put them across from each other or some distance away, and they measure the angle that each of the theodolites need to do to see each other right in the same spot. So they have typically these are done now automatically. So they have an automatic adjustment to measure throughout the course of the day the different angles. So this particular measurement here study finds that except in the most extreme conditions, distant objects are always raised higher. So we can be certain that this hotel has not been lowered by refraction. It has in fact been raised by refraction. So that goes for all these measurements, except for perhaps if it's in some extreme conditions. But these conditions are not extreme. They're pretty normal, typically overcast. I'll give another. Let's see here. This summer, I was in Alaska, and flying back from Alaska, I took this picture in the airplane. It's the middle of the night. You can see the GPS coordinates at the top. My cell phone was on, and it was not in airplane mode. And I was able to get a GPS signal, but no cell phone signal. You can see there that the moon is below eye level. So this theodolite app is accurate to 0.1 degree. The iPhone 7 Plus that I was using is rated to be accurate to 0.011 degrees. I had calibrated it the day before at the mouth of the Kenai River in Alaska, which is right on the ocean. So I know that it is calibrated correctly. And if you look at that, you can see the moon is actually below eye level. And somewhere even farther below the moon is the horizon, which you can't actually see in this particular image very well. It's got clouds that are kind of covering it. But the point is that the moon is below eye level. Certainly the horizon isn't raised up because it would obscure the moon. And then I will go to one more thing, which is a collection of measurements from New Zealand, and I put that there in the link in the chat. This was done by Robin Bodley in New Zealand. He used just over 10 different geodetic survey markers. He labeled them all. You can look them up on the link that's on there. And the New Zealand government has these latitude, longitude, and elevation numbers. And at all of these different points, he measured using a theodolite. He has pictures of the theodolite that at each position and where he took them. So you kind of have a bit of a reference. He measured them all, and then he plotted them out on a piece of paper using Gauss's plus 0.13 for refraction. Because he was at a somewhat high elevation, that's an appropriate number, and found that it matched the prediction for the radius of the Earth very, very well. And that graph is in that link there. So there you go. Those are the horizon not rising to eye level. If the Earth were flat, then the horizon would need to rise to eye level, and in fact, due to refraction, would need to be above eye level, because refraction will cause things to raise up. Yet we never find that in any of these issues. So, or any of these measurements. So that's all I have. I know maybe it wasn't quite 10 minutes, but that is my presentation.
That's fine. That's fine.
Yep.
That's awesome. We've just lost Bev to the Discord gremlins.
Oh, no.
He'll be back any second,
Oh,
though.
okay.
It's all happening this evening. Apology.
Yeah, everybody's using
his PC,
the internet for some
his PC
reason.
went down. Yeah, I know. Yeah, we're all locked up, stuck at home, so... Are you back with us, Bev?
Yeah. Am I back?
What happened there? You crashed?
Yeah. It just the Discord decided to close up on me.
Did you hear how much did you get?
Let's see. Have a look. I saw Jesse, and then you were just going into your next one.
Okay. If I'll just review quickly. You see the links there. After Jesse, is a picture I took from an airplane.
Okay.
Flying back from Anchorage, Alaska, middle of the night. And I had calibrated the theodolite app the day before, and you can see the moon below the eye level. And then the final one is just over 10 measurements from New Zealand using geodetic survey markers. And they match the dip of the horizon matches the curvature of the Earth. So, and in all of these observations, the horizon never actually rose to eye level. If the Earth were flat, it would need to actually be slightly above eye level due to refraction, but we don't observe that.
Brilliant. So. Thank you for recapping.
Yep.
Okay. Oh, yeah.
Okay, take it away, Beth. Do you want me to show your live stream?
Yeah, you can if you want. I'll try and do the pictures or whatever. Okay.
Hang on. Of course, it's not loading.
Yeah. There's no need to worry about it. Don't.
Okay, we'll see if it will load, but yeah, carry on.
Okay, so, like as I was saying at the beginning, I don't know whether we caught that or not. But I initially came into this just as an average person with his son, taking pictures. Like I said, we got into a discussion about the horizon rising to eye level, to which I said quite naturally that don't be silly, a level cannot rise, it's a horizontal. So the initial argument came because somebody called me a child abuser for saying that to my son. The level is a straight line on a horizontal plane, which took me aback. But you eventually end up with I don't know, truths or whatever. You get to find your own proofs through searching for finding out why somebody would call you something like that. So I initially went to go and find out a proof that level was horizontal. So initially I started looking on the canal because we went to Bedford levels test, and we'd done that, thinking that the water level is horizontal, and wondering what was going on. So the initial thing was to work out how to do that, how to get my own proof that the level is horizontal, as is known everywhere. So initially you have to start off with the basis of this is a straight line, and through the geometry which surveyors use Euclidean geometry, you find out quite simply that a line is a point between 2 points, a straight line. There's no definition of a straight line needed, because everybody should understand that a straight line is the defining mark. So from the basis of a straight line, you can then work out what a perpendicular is. Well, within Euclidean geometry, these words are defined within geometry. So a perpendicular is a straight line standing on another straight line, makes the adjacent angles. Toons, can you mute, please, mate?
Yep, sorry.
You're tapping your keys quite hard. So when a straight line standing on another straight line makes the adjacent angle equal to one another, each of the angles is called a right angle, and the straight line which stands upon the perpendicular to it. So there has to be a line bisecting another line with right angles. Now, that on that line, and that's what makes a perpendicular, as defined within Euclidean geometry. Now, the geometry proves this. Think about it. These two lines that are called perpendicular to each other are as geometrically as opposed as they possibly can be. 90 degrees in between. There are 180 degrees on a straight line, so 90 degrees is exactly half of that. Now, there's multiple ways to do it within geometry, but it's provable because it's geometry. It is mathematics. So if the perpendiculars are defined within geometry as being 90 degrees opposed, as stated Euclid's elements for definitions within the axioms of Euclidean geometry, then that is how a perpendicular is defined. Now, you need a straight line to make a perpendicular to that line. Now, both of these lines have to be straight. You can't have a perpendicular to a curved line, and you can't have is perpendicular to a straight line that is perpendicular to a curved line. It's just not possible for the 90-degree angles, which is also one of the other axioms. Is all right angles are equal to one another. So then, okay, so we've the perpendiculars are defined within the geometry. Then what are we talking? So we need to redefine level now, or find the definition of level.
Hang on, Bev. I don't know if you want to rejoin because your sound is choppy. I don't know whether
Sounds bad.
McTunes is having the same issue.
What with me? Can't hear me.
Yeah, a bit choppy.
Okay.
I mean, if it's fine for McTunes, then
Hello.
okay.
Better.
Yep, seems fine now.
Okay. Where did you get to then?
I got it all.
It's
You
you got it.
understand it? It's just choppy.
Yeah, it must be my end then. So carry on,
Okay.
ignore me, and I'll just go with everybody can hear fine. It's just my end.
Okay, so we'll go with we have to find a definition of level. Now, if you ever look at the definitions of level within dictionaries, anywhere, the best definitions you will find, they are always horizontal. Level is defined as horizontal. It's known as horizontal. You can look in any dictionary, and any definition as being level is horizontal. As stated within the geometry, the geometry can prove perpendiculars, and level would have to be horizontal. There's nothing else it can be is other than horizontal. That's what it's defined as. There's no if. Vertical is defined by a plumb bob. Level is defined by the water level. Horizontal is level, and a plumb bob is vertical. The two are perpendicular to each other. I would then state that the water level being horizontal is what defines a horizontal, is the water level, meaning the surface of liquid water would define the horizontal. That would be also defined as perpendicular to a vertical, and if a horizontal is perpendicular to a vertical, the vertical's a straight line, the horizontal has to be a straight line. Unless you have to use a different geometry. Euclidean geometry would define that, and within Euclidean geometry is used by surveyors. So then I came to find a canal. I happened to live in an area where we have a canal, and I noticed that the Liverpool, and it rises up to the locks, and then it travels for 27 miles with no locks, and it passes through the bit, we're near close to me. So the level in the water in the canal is known as horizontal, and it is 27 miles long. Now, I would say if the water level is known as horizontal and you were to drop a plumb bob to the water level anywhere along that canal, 27 miles, the plumb bob would hit the water level perpendicular all the way along it. That'll do for now. But that's the geometric proof that water level is horizontal, and we can take it from there. If you, is that about 10 minutes? That
Yeah, perfect. I apologise for. I should have said that McTunes wasn't on mute, but my daughter comes in at that precise moment. Sorry, Bev, making you do that. That sounded terrible. Okay, guys, thank you for that. Now we're going to go up to 5-minute rebuttal. So take it away, McTunes.
Okay, well, that is all a great hypothesis, but there's no measurements involved in it. So in the end, it's nothing more than a hypothesis that could be tested. I kind of figured that you might show some evidence, but I guess not. But fortunately, this has been tested. Jesse Kozlowski again has tested it, and I'll pull up his page just a second here. Jesse Kozlowski blog. So he did a let's see, and I know you've seen this, Bev. I don't. Let's see, Level Lake. So he did what you basically, he tested your hypothesis to see, well, is level actually, are plumb bobs perpendicular to each other? That's kind of the question, or sort of parallel to each other, and he found that they are not. So we're looking. Let's see, I got a transition on my screen here. Oh, that's the wrong one. That's fine. Anyway, so I gave you that link there. The very first one is a view through his theodolite across the lake to another theodolite, and we can see that it is not targeting the theodolite right in the center. Now, both theodolites were set up at the same elevation, and he goes to great lengths to measure that they're at the same elevation. He has a couple pictures in there showing how he did it. Bev, I know you in Twitter had mentioned something about the accuracy, but of course the pictures that he took of the measurements aren't the measurements. The measurements are the measurements, and he didn't have the camera for that, right? So he found that from both sides of the lake, they diverge. And I'll show you a slide here. They call it reciprocal zenith angles, and there's a little link there to the reciprocal zenith angles. Oh yeah, here I see you're scrolling through there. So he found that they do not, in fact, line up, and then in the end, he did the math and found that rather than 180 degrees, which is what you'd expect from 180 degrees if it were flat, over a flat surface, he got where is it, 90 curve dry. He got 0.15 curve. That's feet. 0.15 feet over that mile. It's just over a mile. So matches pretty well with predictions. Second, and this is more important, level is not defined as you did in surveying, which is where it's really important. Level is defined as a curve conforming to the surface of the earth. I have 45 different examples of the definition of level on this webpage, mctoon.net/level. And I put it in the link there. And the first one I'll just do the first one. I'm not going to go over all of them, but it's from the Theory and Practice of Surveying, containing all the instructions requisite for the skillful practice of the art in 1814 is this version. This particular one was this book was published in the late 1700s, and this is just an update to it. But the definition of level, the true level is a curve conforming to the surface of the earth as ABG, and then that's in the graphic there. So level is defined as a curve and has been measured to be a curve, as Jesse Kozlowski measured. Also, there's others. If we want to cover other measurements, it's been repeated. I have several others that we can pull up as well. So there is that's my rebuttal to that. Thank you very much.
Okay, Bev. Do you want me to put up the live stream?
Yeah. Well, no, I'll do this with pictures. You just check this.
Okay,
Yeah,
take
I'll
it
try
away.
and find it. Yeah, your level isn't curved. That's absolutely ridiculous. I don't know who's been towing you that. Was it Cosmo? And then no, 5 minutes. So and then also you've got the main surveyor who's done. He's measured angles more than 180 degrees. Is that a straight line? More than 180 degrees? I don't know whether you realise how ridiculous that is. But I think what you're trying to tell me is you've got a surveyor who's told you that he has disproved Euclidean geometry by using Euclidean geometry. It sounds fantastic, and I don't know why you've believed him, but that is ridiculous. You cannot measure plumb lines that are not parallel, because his frame of reference is the very vertical he's working on from. And if you realize that a vertical and a horizontal are perpendicular, but if you're doing what he says, and especially with that picture there, it's impossible. It's impossible to disprove geometry using the very geometry that you're using. Him being a surveyor should know that. Shocking. What else have we got? Oh, is water over the thing. So Jesse, is that Jesse that's done that? Yeah, Jesse has measured water that drops away from you as being level. At 1.5 foot over 1.5 miles. Did you say? I think that's what you said. Can you? That's got to sound a slightly bit ridiculous. That saying that the level of the water drops away 1.5 feet over. I don't know. So yeah,
It was not that much.
Is that not what you said? No, 1.5 feet over something. I don't know, but I will be going over this, and I can go over it much better if we want to go into whatever. There you go. I'll come off live. I could do with showing you a picture of my water level, but I mean, yeah. If you want to open up the questions now.
I thought open discussion would be next.
Yeah. Yes.
Okay.
Yeah. Sorry. I'm definitely having sound issues.
Is that me or?
No. I think it's my end. Even the hardwired is having issues this evening. So it's probably just due to the amount of people online. But it's fine. You all sound fine. It's just I'm having difficulty hearing you guys. So apologies for that. Yeah, up to 30 minutes of backwards and forwards. Obviously, keep it civil, and I shouldn't have to step in. So carry on.
Right. Well, can I just say that I say that level is horizontal, and that's what most of the dictionary definitions say. And the geometry, like I said, the geometry states that level is horizontal and perpendicular to vertical. Now, you would agree with that, would you? Or
not?
Do you have a different definition of perpendicular?
Well, perpendicular to zenith is a line, absolutely, and it will fall away from the surface of a curved surface.
What will fall away from the curved surface?
So if you're on a curved surface, and you like, say you're on the surface of a sphere, and you get your zenith, which is straight up, and then you have your horizontal, which is 90 degrees from that. That will be a straight line. As that straight line goes farther away from you, the surface will drop away. If you're on a sphere. And if you're on a flat surface, the surface will not drop away. It will remain the same. So the question is, what do measurements say? Not what does ideas say, and theories say, hypotheses. What do actual measurements say? Does the surface drop away from that line?
Okay, so can I give you have you seen the meme that was done by Jesse? Because that's Jesse. Is it Jesse's, or is that the main surveyor's thing there with the 90 degrees and the is that's what you're using as your references, intersecting horizontals?
That's an example of reciprocal zenith angles.
Right. Do you know what that is, a reciprocal zenith angle?
Yes.
Right. So that would be if you were going like up a mountain.
Well, you can do it on you can do it on a flat surface or a curved surface. It doesn't matter. You can be at the same elevation or different elevations.
You can do it in reality, can't you?
Yeah, and there's the main surveyor has a bunch of them.
Yeah, I know. Right. So let's just take it that you're at the beach, right, with the water lapping up at your feet. Now your zenith is above you, so the zenith to the horizontal would be to your feet. Yeah.
Okay.
So the horizontal would be going out from your feet, and that would be the horizon on the water level.
That would
keep going out.
That would be horizontal. That would be the line defined, or the plane defined as horizontal.
Yes. So from the water level, from your feet, would go out towards the horizon horizontally.
Yes.
True?
Yep.
Right. Then if you walk, let's say you're walking up, there's a mountain right at the side of the beach, and as you're walking up, then as your zenith is going up with you, then the 90-degree horizontal would rise from the sea level to whatever level you were at, right? There would be that distance difference, right?
Yep.
So that horizontal would go and continue over the water level at the same distance, wouldn't it?
Yeah, and if the surface curves, then the surface will drop away from that plane, and if the surface is flat, then that surface will not drop away from the plane. That distance will be
horizontal.
Yeah. So then you measure it. You measure it to find out which is the case.
Yeah.
Yeah.
To find out that water level is horizontal.
What you'd find out if the plumb line, the plane defined as orthogonal from the plumb line, you'd find out if that matched if the surface dropped away from that or not, is what you'd find out by measuring it.
Yeah, but the water level would be the horizontal, wouldn't it?
At your one point, absolutely, that would help you to determine the plane that is the horizontal to the orthogonal plane to plumb.
Well, a water level, the tool.
Yeah, it defines plumb in one point.
No, it doesn't define plumb at all. Plumb is completely separate from level. They are two independent things, aren't they?
No, they're permanently bound together. They're 90 degrees from each other.
Yeah, but they are independent tools. Like a plumb bob is a different tool than a water level.
Have you seen? Well, no, not at all. Have you seen the water levels? Have you seen
of them's a big weight on the string.
Have you seen the water levels that don't just have one bubble in it, but they have another one the other direction? You can turn your water level vertical and then use it to measure plumb.
You can't turn a water level vertical, mate.
Oh, you just go down to the hardware store and buy one that has two bubbles in it, and a lot of them have three bubbles, the diagonal ones. You get 45 degrees.
You don't know what a water level is, do you?
I certainly do. I own one.
Right, and has it got two bubbles in it?
It has three bubbles in it.
Right, and how big's the tube?
The tube is small. Why?
Well, because that's what a water level is. It's actual water. It's
actually not water at all. It's typically methanol. It's almost always methanol.
You're thinking of a spirit level.
Uh-huh.
Right. I'm not talking about a spirit level. I'm talking about a water level.
Okay, and you buy this at the hardware store?
Have a look in the chat. It's one of the simplest tools that ever has been.
Okay.
It's just a hose pipe with two vials at the end of it.
Sure.
And you fill it up with water.
Yeah. Okay.
Right now.
So that can be used to identify the plane that is the horizontal from where you're at. Yes.
Yep.
And so the question is that plane that's defined at one location the same plane as measured at another location?
No, Toons,
I'm sorry.
Completely missed it again.
You don't need to interrupt my sentence, okay? Is that plane defined at one point the same plane as it is defined at another point? And the way to find that out is to measure.
Are you done?
Yeah.
Right. I know you've only just found out what a water level is.
Sorry, I haven't.
So you did know what it was about then. Have you have a look in the live stream, please?
Yes.
It's a tube with two vials on the end of it, right? With water in it, right? There's no moving parts. There's no calibration. There's no fancy moving technical bits. It is literally water in a tube. Now, the level that is defined by this tube is the bit at one end and the bit at the other end. And then what you can do is you can put a line all the way through from one end right through to the other. So when you say it is defined as horizontal at one particular point, which point are you thinking of?
Yeah, so that's a good point. So that would be horizontal. That is the average between those two. The average distance between those two would be the plane, the existence of that plane. If they're very far apart, then and if you're on a curved surface, then you need to use the center point of between those two.
Right. So it's only the bit right in the middle of the plane, of the horizontal plane.
Yeah, that is tangent to the curve if you're on a curve.
Okay. Do you know what a plane is?
Of course I do.
Mathematically speaking.
Yes.
And there's no curve in the plane, is there?
Absolutely not.
Right. Okay. So if you have a horizontal plane referenced by a water level, then when you say you want to reference the center point, you understand that if it's a horizontal plane, then that center point is exactly the same all the way along.
Yeah, I'm talking about if you're on the surface of a sphere.
I'm not talking about if you're on the surface. I'm talking about reality and what a water level does.
Sure, and so
reality.
Yeah. So then I'm drawing a hypothesis here, right? So if you're on a flat surface, then that plane will be the same no matter where you are on that flat surface. If you're on a curved surface, then you would find the tangent of the curved surface would be the center point of that plane, the center point between the two water tubes.
Yeah, the horizontal plane.
Yes, that would be the tangent to the surface, the curved surface. So
Surface?
The curved surface. If you
Tangent to a horizontal plane.
no, the tangent to the curved surface would be the horizontal.
Which curved surface, please?
If you're standing on a sphere, then
Can we just deal with reality, please?
we are.
I don't.
I'm doing a hypothesis here, right? That's how we test things, right? So the hypothesis, I'll back up again. If you're on a flat surface, on a plane, then it doesn't matter where on the plane defined by that water level, it's going to be the same distance from the plane that you're on. If you're on a curved surface, on a sphere, then the tangent to the sphere would be something that you could find with a water level, and that would be the center point between the two tubes.
The water level would give you a horizontal plane.
Absolutely. Yep. And that plane would be...
Where is the curve?
Well, the curve is not defined by that plane. That is the horizontal plane that the water level defines. The curve is measured, not defined. The dictionary doesn't tell us what the shape of the Earth is. Measurements tell us what the shape of the Earth is. Right? So you just have a hypothesis that it's flat and that we live on a plane, and we also have a hypothesis that we're on the surface of a sphere. All of this...
You have that hypothesis.
Absolutely, yeah. So then what we do once we have our hypothesis is we go test that hypothesis. Do you have any tests of that hypothesis?
A water level defines a horizontal plane.
Yes, but does that horizontal plane defined by that water level drop away? Does the surface... Hold on.
It's horizontal.
Just a second. Does the surface of the Earth drop away from that horizontal plane or not? That's the measurement that we need to take. So do you have that measurement? Whether or not that...
horizontal.
A measurement of whether or not horizontal matches the surface of the Earth or whether the surface of the Earth drops from that horizontal. Right? So I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that. The question that we need to answer is, does the surface of the Earth drop away from that horizontal plane or not?
Well, if the water level is horizontal, then I would say I'm not so sure where your sphere is coming from or your curves.
Yeah, but
if the only reference you have is level, which is horizontal, then I would say you would need to measure a drop in the level, but level is your reference, which is horizontal. So how do you measure a drop in a horizontal? That would be my main question.
You measure a drop from the horizontal by using a theodolite, setting it up to match the plane that is horizontal. And then you measure your zenith angle from that plane to see if things that are farther away drop or not, which is what we did. That was the first, my presentation was several measurements of drop from horizontal. And with increasing elevation, there's increasing drop.
Well, yeah, that's obvious because, like I explained to you earlier, that the higher you rise, the more difference within the two horizontals there would be.
Yep, and we can use
you agreed to
it. Yeah, we can use Euclidean geometry to find out to predict how much of a drop we should see on a surface that's a sphere and on a surface that's a plane.
Sorry. You say you could use Euclidean geometry to do what?
To measure the drop from horizontal for a plane and the drop from horizontal for a on the surface of a sphere.
Right. Well, do you understand that a vertical in Euclidean geometry is perpendicular to a horizontal?
Yeah, you keep going over that. We've already established the horizontal plane.
No, let me finish. If you walk along that horizontal and then build another perpendicular to it, and then walk a bit further along and build another perpendicular on the horizontal, then verticals are parallel, aren't they?
If and only if you use the exact same horizontal plane.
In Euclidean geometry is what I'm talking about.
I'm talking about reality.
Yeah, so am I.
So if we walk from one place and we get our plumb bob, and we use our horizontal, we get our measure, our horizontal plane using a water level, then we travel a mile away or a tenth of a mile away. It doesn't really matter, right? And then we do the same thing. Now we can measure to find out if that plane at both of those locations is the same plane. Right. So since we can measure that, then we do that. And as you mentioned, Jeff, the main surveyor, already did that. So I'll pull that up.
Jeff, first main. What did he do?
He measured whether or not he used reciprocal zenith angles, right? Which is plumb.
Yeah.
Plumb is perpendicular from horizontal.
Yeah. Yep.
So he measured to find out if plumb at two locations are the same, and he found that they're not.
Oh, they're not what? They weren't plumb at the location?
They were plumb at the location, but the plums were not the same. They were not parallel to each other.
How did he work out that the plums weren't parallel to each other?
Well,
did he tell you that? Or can you explain how...
Yeah,
he worked out that the verticals weren't parallel.
I pasted that picture in there for you.
Yeah, I know. That's just a circle with a few lines on it.
Yeah, so that's how you...
nothing level there.
Well, you're asking... Hold on. You're asking how to do it. I'm telling you. It's Euclidean geometry.
Yep.
Right? So
that's just a circle. Yeah.
So you get a zenith at one location.
No, that's just a circle with a load of drawings on it. There's no zenith.
All right, I'll explain how you do it. Okay, you get a zenith at one location. Right.
Not on that. If you're doing Euclidean.
I'm sorry.
Hang on, guys. Hang on. Bev, let them finish. I know this is your favourite, but yeah, let them finish. Thank you.
Thanks, Emma. So yeah, you get a zenith at one location, and you measure, and then you do the same at a different location. You get two theodolites is the best way to do it. You then measure your zenith angle from each one of them to the other, back and forth. So you have, if they're at the same level, then they'll both be at 90. Now, if they're at different levels, and I'll grab the image address here. If they're at different levels, elevations, then they won't be near 90. They will be apart from 90. But when you sum them together, if they're on the same plane, they will sum to be 180 degrees. If they're on the surface of a sphere, then the sum will be over 180 degrees. So Jeff, the main surveyor, did this 5 times, 2 different points, the same points, different days. The first day, he found that they diverged from each other by, let me see here. I'll put the website where I summarize his measurements, because it's 5 different videos, but we don't want to look at all these videos just to pull it out. So
he proved that verticals aren't perpendicular.
He measured that plumb lines diverge. Yes, he measured that. So there it is. So
he disproved Euclidean geometry.
Not at all. He used
Euclidean geometry.
Not at all. He measured to find that the surface of the Earth is not flat. That the surface of that plumb lines. Okay,
so
hold on. He measured
vertical and horizontal, are we?
No, he measured that plumb lines are not parallel. That's what he measured. On the surface of the Earth, plumb lines are not parallel.
Disproved perpendicular.
They are not perpendicular.
Vertical, horizontal.
No, what he measured was that your assumption is wrong.
What do you mean, my assumption?
You're.
I'm just using perpendicular from Euclidean geometry.
Yeah, but you're assuming that you're on a flat surface.
No, I'm assuming that vertical and horizontal are defined as perpendicular.
Yeah,
then I am using that definition of perpendicular as defined by Euclidean geometry. That's all I'm doing.
Yeah, but you're doing
You're
it at
the
one
that's
point.
saying- well, no, I'm not. I'm using a water level.
Yeah, that tells us horizontal at one location.
Horizontal.
For one
no.
location. Not for all locations, just one location.
If the body of water is 27 miles long, then that is a 27-mile long level stretch of water.
Well, that's a hypothesis.
It's not. It's an actual
well,
canal.
yeah, I'll agree that 27-mile long thing is level, because level is defined as a curve. And
Right, so that's not horizontal then. The water level.
the entire
isn't
surface
horizontal.
the entire surface of the water is not in a single horizontal plane, correct?
Right, so we go back to a water level again. Can you see my live stream? Because I've got a little thing.
I cannot see your live stream, no.
Will hopefully show you a water level and how a water level works. Can you see it, Emma? Or
Yes, I have put it on the screen. It is finally working.
right. Now, Toons, you'll just have to imagine. Do imagine with me. You've got a water level as defined as a tube, but it's in a canal, let's say 2 miles long, and it goes from one side to the other. Put it exactly at the same height as the water level. This is my water level test that Sly keeps shying away from talking about. So you can have a go at this. So the water level, the initial water level, goes all the way 2 miles, one side to the other. Same water level. Now that water level defines a horizontal plane in between it. I think that's what a horizontal water level is. You say it curves, right?
Yeah, as measured. Yep.
Okay, so now this curve of the water level, does it drop from your point where you are, or does it rise to a lump in the middle?
You will find that it's curved. So as I said earlier,
Yes, I'm asking how does it curve? Does it drop away from you, or does it rise up to end up level? Because a water level is horizontal plane. That's what it does. It's industry standard. That's what everybody knows. Level is horizontal.
You're perfectly contradicting the entire surveying industry. You don't get to tell the surveying industry what level is. They get to decide it. They have defined it for over 200 years to be a curved surface. So
what is the amount of curvature in level?
You don't get to tell them what is level. They get to tell you what they use for level.
Okay.
Guys. They've defined it.
Okay, guys. Okay. No one can hear what either of you are saying when you're talking through each other. I think we could probably go on this subject all night, to be honest.
I'd really like to get him to have a look at this thing with the water level, because I honestly don't think he understands what a water level is.
I have a great understanding of it.
Okay, well, I did post a screenshot of what you did.
Okay.
In the live stream. So,
can you see that then?
I can, yes.
Right. Can you see that the black tube goes from one end to the other? Yeah, that is a water level. That's what it is. It's just a water level. It's the water within the tube finds its own level, as water does.
Yes. Yep.
To find a horizontal condition. Now, the point all the way in between that bit, because it's a water level, you could move them closer together, further apart. They would stay horizontal. Would you agree with that?
So here's the thing. Where are your measurements?
Oh, come on, Tim. It's horizontal.
Sorry.
What measurement do you want?
I want you to show some measurements.
It's a horizontal line, right?
Okay, so
that's the point.
So you have
it's horizontal.
You have a hypothesis, but no measurements, no evidence. Thank you.
No, I have a horizontal tool that defines a horizontal in its natural state. It's you that don't have any measurements.
Actually, I showed you a bunch of measurements.
Remember that.
I showed you several measurements, and you showed nothing.
Yeah, they're just some guy looking through a thing, writing some numbers down.
Which is more than you did. You did absolutely nothing.
It's horizontal, right? So there's two water levels. Yeah, there's two water levels within this thing of mine. So the initial one from the outside is 2 miles long. So you've got two more water levels within this thing. Now, can I get that? Do you want me to get a picture of it, or can you go to?
Were they taken outside with at the actual?
They are
canal?
Other levels, right within the canal. It's in order to show you that the water level is horizontal. Because you seem to keep thinking that you have some sort of curved surface somewhere.
Yeah, it's been measured.
So the water level, horizontal, is curved and measured curvature, is it?
The surface
of the Earth,
the surface of the Earth has been measured to be curved. Yes.
Surface of water.
Absolutely, as defined by the surveying industry as well.
It's measured as curved.
Yes.
Right. Okay. So the water level curves. Does it curve away from where you are?
Yeah.
Constantly. Does it always curve away from you?
Yes.
Right. So when they say water finds its level,
yeah, they mean a surface that's curved.
But it would always be dropping away from you. That's what you've just said.
Absolutely. Yes.
Right. So water finding its own level means it's always falling away from you. Is that what you're saying?
Yes. Thank you. You get it now.
Okay.
Congratulations.
Okay, so do you have a measurement of how much this water level curves over a mile, please?
Yeah, I sent it to you. It's the Jesse Kozlowski's measurement. 0.15 feet drop across that lake. I'll post the link again here.
0.15 feet.
Yes.
0.1.
0.15 feet.
Over how far?
That is. Let me get the. Well, it's in that link there.
Yeah, I know. Like you should know. It's your it's not. You don't just post links, do you? It's 1.15 feet, which is, I don't know. What's that? Just about 2 inch or something? Maybe touching 3.
Yeah,
if you're lucky. Yeah. How far?
I'm sorry, I don't know offhand exactly the. I know it's around. It's near a mile. Yeah.
Oh, and what? And he's only managed to measure 3 inches.
Yeah.
He's got the water level dropping 3 inches over a mile on the lake.
Oh, there it is.
Is it
0.48 miles.
0.48 miles. Did somebody just fed you that? Is that how much?
No, it's if you look on my live stream. If you look on my live stream right now, you can see the table. He says final results produced from a least squares adjustment combining all the observations on my YouTube channel.
Oh no, I can't see that.
Yeah. Well, you were accusing me of having somebody fed that to me, and
no. I was saying
So there you go.
Right. So is that from one side of the lake to the other?
Yes.
Right. So it's lower on which side of the lake?
Well, both sides.
What? Oh, right. Oh, so it's lower on the side whichever you're measuring it from.
Yeah.
So when it's lower on one side and then you go over there, then that's the high spot then. And you're measuring lower on the other side. Because that sounds sensible, doesn't it?
That's exactly how it works, yes.
That's exactly how it works. Then you never know whether you're the higher or not, or you are always. I mean, like, what would happen if there were two surveyors, one on each side?
That's what this reciprocal zenith angle thing is doing, yes. It's you could have two people doing it at the same time, but when one person does it, you just travel between them.
Yeah. So, like, one guy's on one side of the lake and he's going, hey, I'm higher than you.
Yes.
And the guy on the other side's going, hey, no, I'm higher than you.
Now you're getting it.
Do you seriously? Does that work in your head?
Yeah, I'm sorry. If you don't understand it, that's fine, but that is how it works on a surface of a sphere.
What?
Everything,
you never know who's at the top.
Everything
falls.
Everything falls away from you, right? So you have at your position, you can get a plumb and you can get a horizontal plane. That horizontal plane, everything falls away from that horizontal plane on the surface of a sphere.
Right. So on the surface of a sphere, the water level isn't horizontal. Is that what you're saying?
No, the water level at your point defines a horizontal plane.
But that's not how a water level works, Toons. Is it? At your point isn't.
No, actually, that is how a water level works. There you go.
No, it isn't.
So yes, it is. No, it isn't. Yes, it is. No, it isn't. So that's the deal. And of course, he's not using.
The water level is 2 miles long. Which point are you talking about?
That would be the center point. We covered that earlier as well.
But the center point of a horizontal plane is the same, isn't it?
Yeah, but it's the tangent to the surface. As I said, this is just
tangent to the horizontal.
So here, just simple geometry. If you have a 2 mile long water level on the surface of a sphere, then the center of that water level is the tangent plane to the surface.
Is that higher than the both ends of the water level?
Then it would be,
that
yes.
Center point?
Yes, it would.
Would it?
Yes.
On a sphere, the center of a water level would be higher than the outside tubes.
Correct. Absolutely.
McToons 2020.
Absolutely.
Yeah?
That is how it works
so
on the surface of a sphere.
If I could prove to you that a water level was horizontal, would that disprove your sphere?
If you had measurements, absolutely. Got any measurements?
That water level is horizontal.
Got any measurements?
Yes, you want me to provide you with measurements that the water level in a canal is horizontal.
The entire surface of it, yes. Is the surface of that water of that canal? Is it matching a plane or does it curve? That's the question. And you haven't provided any measurements. You've just gone to a dictionary and said the dictionary says this on a plane, therefore we're on a plane. But you didn't test it. You didn't measure it. You're just making claims and assertions. Since you have no evidence, I'm just dismissing all of it. I have evidence. And you don't like it. I know you don't like it because it completely contradicts your assertion. But it's been measured, and I presented the measurements, and you just didn't like it. So if you don't like it, perfect. Show some measurements.
Of a horizontal plane. Like, because that is what a water level does. It defines and establishes a horizontal plane.
Okay, got any measurements? Yes or no? Is that a no?
Of a horizontal tunes? No. What?
Do you have measurements of the surface of the water?
It is
not
your datum.
Yeah. It is not actually.
All measurements are taken from.
So
yes.
So no measurements then. So I
that's
provided
I think
provided
how you
measurements
measure the
and you didn't.
altitude is by taking measurements from sea level.
Yeah, like
So-
NAD 88 or WGS 84. Both of those are ellipses.
Is that a measurement?
Well, you're talking about datum for elevation, and I agree.
Horizontal datum. Yeah,
It's elevation datum.
yeah,
is what-
horizontal from sea level.
Yeah, they don't call it horizontal from sea level. They call it an elevation from sea level.
Yeah, it's level.
Yes, it is level. The surface of level is a curve. So
No, it's not. It's horizontal.
well, do you have measurements to support your claim? You don't. You have
water
nothing.
level defines a horizontal plane. It does-
At one point, yes.
No, not at one point.
Only at one point. So you're making this assertion that your 27-mile long canal is a plane, but you don't have measurements of it.
Okay, so let's just stand on. Let's get in canoes on the canal, right?
Okay, go ahead.
It's funny, is it?
Yeah,
Right,
because
okay.
you have no measurements.
You're on a canal, right? The canal that leads to Liverpool Canal. You're at Vauxhall End. You can be in a dinghy, you can be in a dinghy at Vauxhall End in Liverpool. I'll go to Apley Bridge, 27 miles away. I mean, it's 15 miles as the crow flies. So how do you want to do this? 15? Is that easier for you to handle?
You could use. You don't have to use this one thing. You'd want to have something where you can see a good distance of it, of course. Yeah.
This is a canal of water.
Mm-hmm.
Right, okay, so you're at one end, I'm at the other end, and let's put Emma in the middle.
Mm-hmm.
Okay? Now, if we all drop our plumb bobs to the water level, would they be perpendicular
Not at
to
all.
the water level?
Not at
No.
all.
So,
Sorry.
wouldn't
Sorry,
be perpendicular?
they would all be perpendicular to the water level, but they would not be
Fantastic.
parallel to each other. They would diverge.
But no, I'm not talking about that. We're just talking about perpendicular to the water level. Right?
Okay.
Then who would be the highest? Like if you was to measure, would you go Emma and Bev, you're both lower than me?
If from my point of view, you would both be lower than me, yes.
Okay. But I mean, like, this water level don't forget, it's been measured and it's 51 feet all the way across altitude.
Yeah, that's
You're happy with that?
that's
okay.
elevation above a datum. The datum defined,
Sea level.
sea level, which is an ellipse.
No, that sea level is horizontal because it's
Which-
using the word level.
Which
Horizontal.
well, as I already showed you, level is not horizontal. Level is a
Level
curve.
is horizontal. But, okay, but so we're on the canal, and you say, even though we're all at 51 feet elevation from sea level, mean sea level, even though we're all that you would say that you were higher.
From
If you were to
From my point of view, the horizontal plane that I can use, that I can define at my point, which is tangent to the surface, and it's been measured that the surface of the water will fall away from that horizontal plane.
Okay, so and then Emma's halfway down, but she's lower than yours, isn't she?
Yep, but from her point of view, I will appear lower and you will appear lower, and this has been measured.
Okay, appear. When you say, you keep using the word appear, do you mean appear, or do you mean actual geometrically?
Actual geometrically,
Actually.
when Emma would draw a horizontal plane that's tangent to her point, we would be lower than her on both sides.
Level.
Yeah, it would at that point it would be the water level. Because the water level, the surface of the water has been measured to drop away from a horizontal plane.
Okay. So it's been measured for Emma to be the highest, but it's also been measured for you to be the highest on the same stretch of canal.
From where I am, from where any one person is, their horizontal plane is going to be different than everybody else's horizontal plane. That's been measured.
Okay. So if Emma was looking at you while you were up there and you measured yours first, then would the water in the canal rise up towards you from Emma's point of view because you got there first? Or
Because I got there first? It doesn't matter who gets there first.
no? Because I'm struggling to work out how it works in your model.
Yeah, I know.
But with the horizontal plane of water, it seems to work quite well that we're all on the same horizontal plane.
Well, that's a hypothesis.
There's no contradiction. It's not really a hypothesis.
Well, it's not
I'd say
not a very good one, I guess.
Provable
Well,
through
measurements.
geometry.
Through measurements.
Horizontal, yeah. The fact that there is no difference or deviation from that horizontal within the water level would show that there is no curvature. So the very fact that there is nothing to measure as a deviation from the horizontal would show that you don't have a curve to measure. You, my friend, not me, you do not have anything to measure.
Well, except it's been measured, right? I just put in another one there. Well, Jesse Kozlowski and Jeff, the main surveyor.
Have you only got them too?
And myself.
They the only two. Oh, you have measured
Yeah.
the curvature of the water level, have you?
There you go.
What is your measurement of the curvature of the water?
I presented it. I think you were off there. I just posted it in there.
That's a measurement, is it?
I used my Theodolite app on my phone while flying from Anchorage, Alaska to Minneapolis.
So were you above sea level?
Yes.
So that you would predict a drop to sea level?
Yes.
Surely.
Okay. Yes.
And so you see a drop, and I see a drop there, and I would predict a drop because levels don't rise, do they?
Yeah. So in the one that I put in there, you can see that the moon is below
What's the
eye
measurement,
level.
Please?
The measurement is that the moon is below eye level.
No. That's what you see. That's not a measurement, is it? A measurement would require numbers.
Sure. The top of the moon is 0.1 degree below eye level.
The moon?
The top of the moon, yes.
Okay, and that proves that the water level isn't horizontal because?
It measures that it measures that the surface of the Earth curves away from eye level.
The moon?
Yes. So unless
you looking at the moon proves that the surface of the Earth curves away. Can I get a recap on that?
Yeah. Okay.
Please?
So I'll recap that for you. I was at 35,091 feet
above sea level.
Yes, absolutely. So the moon.
Can I just check? Were you 35,000 feet above sea level at the zenith of your position, or like all the way along sea level?
The point I was at was 35,091 feet above sea level.
Okay. So not where you're looking then, that you don't think that that's the distance in between that, do you? Couldn't be, could it?
The distance between what?
Oh, I don't know. You're thinking, I'm seeing a drop there. Let's suppose what you see there at the bottom of that box is the horizon, right?
Yeah.
Yeah. So the difference between the level that is that an app? Is that your, do you have a Theodolite app on your phone?
That's what it is,
Is
yes.
that what that is?
Yeah.
Brilliant. It's fantastic technology nowadays. So that is the distance there is the drop between the level of your eyesight or the level of your camera eyesight, right, and the horizon. That difference is the difference of 35,000 feet, is it?
Yeah.
Yeah.
So now, if
So that would make the horizon of the sea level being horizontal, right?
well, we can calculate how the angular drop of the horizon would be. Yeah.
You'd need measurement, wouldn't you, to calculate something?
Yeah, you'd need to know how big the Earth is.
No. No, that would just be a calculation. You're picking numbers out of somewhere. You wouldn't be measuring anything to calculate, would you? What would you be measuring in order to calculate?
Well, if we knew the size, let's imagine for a second that the Earth is flat, right? No.
Let's just deal with reality. Let's just say.
Oh, it's
what
not.
We see
I appreciate
in
it's not reality. Yes. So
No. Just I'm telling you, don't suppose you're on any model that you think of. Just deal with what you see, and let's talk about that.
Well, you don't want to do science?
What?
Well, you start with a hypothesis here. You don't want to do a hypothesis?
You start with a hypothesis.
Yeah. Well, observations, but early on you get a hypothesis going, but you don't want to do that. That's fine.
So
we can skip.
What science are we doing here?
Well, we can hypothesize that the Earth is flat.
No. Is that science? Is that Earth science?
It is science, yeah, absolutely. To create a hypothesis.
Would that be geometry then?
Not yet. We're not using geometry yet. We're just
okay. So what science are you doing?
We're doing science. We're hypothesizing that the Earth is flat. That's a hypothesis. No.
You need a naturally observed phenomena, don't you?
I'm sorry. I please cite that particular limitation of science in some.
No, I'm just saying. How would you start? Do you just magic up a hypothesis?
Yeah, absolutely. A hypothesis can be whatever you want, anything at all, and then as long as it's testable. Okay. Right. So I'm gonna state a hypothesis. Please don't interrupt me while I do this, okay? Hypothesis: the Earth is flat. We can test whether or not the Earth is flat from an elevation by calculating the dip of the horizon to the edge of the flat Earth. We could also hypothesize that the Earth is a sphere, and if it's a sphere, we can also then calculate and predict using geometry the dip of the horizon from any elevation as well. So let's test that. So number one, if it's flat, right? If it's flat, then the edge of the Earth is very, very far away, at least 10,000 miles, maybe 20,000 miles, right?
Is that is that what you predict?
I don't know. It
horizon.
If it's flat, then at some distance away is where we're going to see the horizon, right?
Yeah, an apparent position.
Yes.
Right.
So okay. the horizon will rise to that apparent position. Now, if we measure that...
No. Whoa. Why would the horizon rise?
Geometry.
What? Like, so a level... is this on your hypothesis of this flat Earth, which is impossible?
Yes. I do agree it's impossible, but yes, go ahead.
No, I'm going to have this out now, right? You said that I said the Earth is flat, right? I'm going to have to pull you up on this now.
Oh, you don't think it's flat?
The Earth, the land, right? Because the water isn't Earth, is it?
Okay.
Do you think?
No,
do you think water's Earth?
Go right ahead and state your claim here.
Okay.
You're trying to dance. Just say it. Just go ahead.
The Earth is the land, and that has mountains and valleys. So, cannot be flat. Okay?
Okay, so typically when I say the Earth, and when most people say the Earth, we talk about the thing we're on, not just the dirt part of it. But that's fine. What word do you prefer for the thing we live on?
What do you mean?
Well, that we live somewhere, right? When I say the Earth, I talk about the thing we live on. And so when I say if the Earth is flat, I'm speaking about the entire thing. So it's the water, the dirt, all that.
But I will give you that the water is horizontal. The water level is horizontal. right? But there's no way we're going with flat because there are mountains and valleys. You can see that, can't you? There is a 3-dimensional aspect to it.
Yes.
Yeah?
Yeah.
Okay. So in order for you to use spherical geometry, which is what you're going to try and use, isn't it?
I prefer Euclidean for this.
Okay, right, brilliant. So Euclidean has straight lines then, right?
Euclidean has curves as well. You can do all sorts of things in Euclidean.
Yeah. But,
Yeah,
the fifth postulate holds true in Euclidean geometry.
Okay.
True?
State the fifth postulate.
Do you want me to? Well, fifth postulate. I may call it. I've got it on my axioms as.
Can we try and round it up after this point, and then we'll go to each have a closing.
Okay, I'm just trying to find this. Right. Okay. So, I've got it as the 12th axiom, but call it the fifth postulate. If a straight line meets two straight lines so as to make the two interior angles on the same side of it taken together less than two right angles, these straight lines being continually produced shall at length meet on that side on which the angles are less than two right angles. That, are you with that? It takes a bit of explaining.
I don't see how that applies, but go ahead.
Well, the verticals are perpendicular. Yeah? Vertical and horizontal are perpendicular.
Sure.
In reality.
In geometry.
True?
In geometry,
No,
yes.
no, not in geometry. Vertical and horizontal are not in geometry. They are in
Sure.
reality.
Okay.
Okay. Now, are they perpendicular to each other?
Yeah.
Okay. Is that perpendicular as defined in Euclidean geometry? Or do you have an other meaning for perpendicular?
No, I have no problem with that.
Okay,
horizontal and perpendicular at a point on the surface of the Earth are, yep.
Right, and also that any line can be extended indefinitely.
A line
As
can, yeah.
Euclid's postulate.
Sure.
Okay, so then what you've just saying is that vertical and horizontal are not perpendicular always.
I'm saying that vertical and horizontal are perpendicular at a point and that they're different from a different point.
Well, that's not Euclidean geometry. You can't do that in Euclidean geometry.
On the surface of a sphere, you absolutely can.
Well, you can't do that with Euclidean.
I'm sorry, you're just asserting the things that you're assuming about the surface of the Earth. You don't have any measurements for it. So
Mathematics is the only way you can get proof, as stated by Fight the Flat Earth. Quite often, he states it all the time. Actually,
well, I would say you also have proof in baking, and you also have you
best tell Fight the Flat Earth. He says science.
I know, and I do have to get with him.
Only.
I have been doing a lot of baking lately, and you have to prove the dough, don't you? Then also alcohol purity has proof. That's another one, and pure math.
Right.
Okay, that would be an awesome time to say thank you very much to you guys. And we'll do a couple of minutes closing. So, Mitchie, take it away.
Me, okay. So, well, thank you very much for having me on, Emma, and it was good talking with you, Bev. I know we got heated, but thank you very much. It was a good discussion. I would have loved to see some measurements from you. Maybe it's something you could do sometime. Rent a theodolite and go out and see if you can do some reciprocal zenith angles. That'd be cool. I'd love to myself. And maybe I'll do that myself someday here too. So that's it. Thanks a lot.
Brilliant. Beth?
Well, I don't know. I think I've stated my case. Level is horizontal. I've never seen anybody come up with any other reason and any other thing to try and prove that it curves. Like, if geometry gives you proofs, as stated by Fight the Flat Earth, then why is it you do not even know which geometry you're using, or even how to use the geometry that you have? Strange that. You just keep talking about models.
Okay. Awesome. Thanks to both of you. Machines, did you have any super chats or anything?
Let's see.
Anybody wanted to ask Bev?
Well, I've got a couple. Let's see. We've got JL Warren says, Bev, do you understand that to debunk the current model, you must understand the current model and explain how your new model makes better and more accurate predictions than the current model, right?
Okay, I'm not proving a model. Like I said at the very beginning, somebody called me a child abuser for saying that level is a straight line on a horizontal plane. That's all I went to do, is to prove that water level or level means horizontal, which it does. I don't know. I came out of it stronger. I got a proof. So I've never claimed to prove a model or debunk any model or anything. I just came to prove that water level is horizontal because somebody called me a child abuser for stating that.
Yeah, it wasn't me, so you kind of...
No.
It's off topic.
No, it wasn't.
It's not off topic. It's the whole reason I'm here. The whole reason I'm here. I was just a normal dude.
Any more questions?
Let's see. No, this isn't a question. Let's see. Somebody says a single water level measurement indicates a line. So,
Straight line?
I don't know. I'm not certain what he was meaning there. So, let's see. Oh, here's the one. Level is having no part higher than another, conforming to the curvature of the liquid parts of the Earth's surface. I guess he missed that definition.
Yeah.
So.
Yeah.
Okay.
That's Merriam-Webster, that is it?
Well, yeah, I think that sounds like it's from
picked from Merriam-Webster because there's a bit they missed just before it. Merriam-Webster definition of level entry 1 of 3, number 3, it states horizontal condition, especially the equilibrium of a fluid marked by a horizontal surface of even altitude. Water seeks its own level. So that water level is a horizontal condition. So the curvature you're looking for is stated a little bit earlier, and it's stated as a horizontal condition. Unless you've got a measurement of the curvature of the water that you seek.
Yeah, we do.
Which is?
Well, I showed you a bunch of them.
Just say it out loud, and then everybody can hear you.
The one that Jesse Kozlowski did over the 1 foot lake, or sorry the
1 foot lake.
Sorry, it's about a half mile lake. I'll put it in the chat again. There you go. Flat.
That was the water level that he measured, was it?
Yes.
It looks like he's looking from a theodolite to a theodolite there. I can't really see where the water is.
Yep. So that's how you measure the surface of water.
How? By looking at theodolites across over the top of the water.
Yeah, reciprocal zenith angles tells you how much curve.
A drop from horizontal, you mean?
It tells you the curve in degrees from one point to another. Yeah.
The drop from horizontal.
Yeah, you measure the drop from horizontal and then use math to calculate the degree of curvature between them.
Sorry?
That's how you measure to see if the surface of water is curved.
So you get two bits and you measure a horizontal between them. Yeah?
And you measure
and then you measure
the zenith.
drop
It's the
from
zenith, yeah.
that.
Yep.
No, the zenith is just the point above your head. 90 degrees, isn't
Yeah,
it?
you measure
90 degrees from the zenith is horizontal.
Yep.
Yep. So then you're measuring the drop from that horizontal, right?
Yeah, technically they're measuring the angle from the zenith, but you can do the math to get either one you want.
No,
Yeah.
technically they're measuring the drop from the horizontal, aren't they? Because they're surveyors. They're not interested in the zenith. They're not doing astrology. They're just bothered about the horizontal.
Well, the measurements that they're putting here are not. Let's see.
I know.
It's
I know. Do you not
here
find
go.
that a bit strange?
The zenith angle 90 degrees
Yeah.
and 10 seconds. So it's measuring from zenith because the theodolite only measures from one point, right? So when you're in one face, the zenith is up, and all vertical measurements are from that zenith. And you flip it to the other face, and the zenith is down actually. So you're measuring from the downward side. Yeah. So you measure on one side. You measure
nadir, right?
Yes. Yep.
Yeah. So one's the zenith and the other one's the nadir, right?
Yeah. So if you look
But
horizontally,
all the surveyors are bothered about is horizontal, right?
no, they measure vertical and horizontal angles, or zenith angles and azimuth angles to be technical.
You really? They just get a horizontal, don't they?
No, the measurements are from zenith or from nadir.
I have a feeling this could go on all night.
Yeah.
I was a bit cheeky and let you two go at it again instead of doing the questions.
Sorry.
No. It was much better actually than doing the questions, letting you two actually discuss and get into it. So I've kind of let you two. I've judged the situation.
Yeah.
Yeah. Thank you to both of you because you've both been civil and courteous and manners and brilliant. That's what we like to see. So much appreciation for that to both of you. So thank you.
Yep.
And thanks everyone for watching.
Thank you.
Yeah. Thank you.
Yeah. And thank you for coming, Tune. So
Can I ask, if you get one of your surveys, do you reckon they would want to come and have a chat and tell us all about how they do this, what they do?
Yeah, I think now Jesse had a while ago kind of retired from it, but I spoke to him recently, and he said he's getting into it a little more, and maybe he would, but I know Jeff certainly would. He's still pretty involved, I guess, at some level. So yeah, I think either one of them might be interested.
Okay.
but I mean, even if they don't want to do a live stream or whatever, just come in and we can have a chat.
Sure.
So yeah, that would be awesome.
I'll send a message to both. Yeah, thank you.
Sweet.
All right.
Yep, it's been awesome. So I'm just going to sign off. I don't know if you want to.
All right. I'm gonna
sign off on your channel.
I'm gonna stick around on my channel. So thanks a lot, guys.
All right.
All right.
Take care. Thank you very much.
All right. Bye.
See you later.
All right, everybody. Thank you. I have the cat here. It's been in the room with me the whole time. I didn't even know. So yeah, this is Raccoon, the cat, and she recently was fixed, so she's much less whiny nowadays. So yeah, well, there's a lot of people talking to me while I was doing that, and I couldn't catch all of them. So yeah, I see there is a little bit of a kerfuffle between Curve Pimp and Sean Hawkins. I don't like drama spilling over into here. Sean and I had some disagreement a while ago, and it's been cool since then. And so I had noticed I had pretty quick. I initially, I don't know if you're still there, Sean. Initially had during a debate, Sean, had enough and I blocked you out, but I unblocked you and stuff. What I don't like is insulting people. So when, in chats and stuff like that, I don't like to see that. And so, Sean, if that's, that's what I have a problem with. So if you're welcome to be here, if you can keep that to under control, and Curve Pimp, I don't know. I'll review the chat to see if anything was particularly bad. Maybe we could just talk. So and solve that. So yes, Tommy and who else? Somebody sent me a super chat on that about anamorphic mind. Yes, right. Yeah, can I make Sean Hawkins a moderator? So I don't know. I'll evaluate that. I don't like people getting timed out for no reason. So, but I also don't like people being rude. So, causing fights and all that. So, Multi Tom Tom I see is in here, and was asking me, "Am I Christian?" Yes, I am. Do you know that most Christians don't think the world is flat? It's pretty much a fringe cult belief system that everybody rejects, except for a couple. So, Sean, I didn't look at the chat and that you weren't insulting anyone. So, when you're here, keep that up, and we won't have a problem. So. AT2 is asking how bad was Bev. Bev was the same. He has no evidence, just the definition and confusions about it, how things work. So we have tonight, maybe that's what Multi-Tom-Tom is going on about. We do have an epic battle tonight. That will probably be... Oh, look at that. I just noticed Captain Kirk is there. How you doing, Kirk? All right. See ya. Epic debate tonight between Crashes RC... your whole name I can't do. Crashes and Factard. They are debating whether or not Canadian bacon is real bacon. So I'm sure it'll be a dumpster fire. I'm going to bring some Canadian bacon pizza and I'll just roast it over the dumpster. So can I at least take away Curve Pimp's mod for abusing it? Yeah, you know what? How about this, guys? Sean and Curve Pimp, can we have a chat on Discord? Maybe. So... Canadian bacon and pineapple. I went to the store. I went to buy a Canadian bacon and pineapple pizza. I don't know. Do you call that? We call it Hawaiian. Is that common? Hawaiian pizza? And A says Canadian bacon is ham. I think it is as well. But Canadians don't call Canadian bacon. They call it back bacon. Weird. Just like, I guess French people don't call French fries, and they probably don't call French kisses. Same with French toast, I suppose, huh? Sean G. Pineapple does not belong on pizza. I don't know about that. So, anyway, that will be at 10 o'clock Central Time. That is just over 3 hours from now. Craven Mordic says, I am of the mind that Canadian bacon is just ham. So you call it... Christ Puncher says you call it ham. Just plain old ham. He's from Canada, so yep. Oh, NA. Pineapple pizza, I might have to unsubscribe. Well... man, I don't know. French fries originated in Belgium. Yep. But what do the French call it? Do they call it Belgian fries? And, here we go. Craven Mordic. French toast is actually called, and then some French words, meaning lost bread. So, pain perdu. I know I pronounced that wrong. That's okay. French people can pronounce English words wrong. Crashes says, I will be making Factard cry tonight. I hope he's ready. It's going to be something. Sean G. I heard Sean G's going to be there and his whole crew or something. I don't know what that means, but how many that is, that's going to be good. So anyway, Bev had nothing as always, unfortunately, or fortunately, I don't know. He thinks pure math of all. It's so weird. All the flat earthers, they hate math, right? Sleeping Warrior will go on and on that 3 minus 5 it doesn't work, right? Therefore, you can't use math. Austin Whitsitt also thinks you can't use math in science. And Bev thinks you can't use anything other than math in science. He balked at the idea of a hypothesis. So... so... Anyway, I'm okay. It was good. It was exactly what I expected. He's a one-trick pony. Level is horizontal. And ignore all the definitions. Level is horizontal. So, if anybody is wondering, here is on my website, mctoon.net/level, is 45 different definitions of level. 44 of them provided by Cosmonaut, who I saw was in the chat earlier. He sent them to me. The first one here is my favorite. It's from 1814. That's why I like it so much. It's been around forever. So it's a curve conforming to the surface of the earth, which is a curve. So you can mathematically make all the claims you want, but the definition doesn't get to be changed. So, Multi-Tom-Tom, will you be at the bacon debate? You should. Then maybe you can have some. So I do have, I didn't finish. I got myself Canadian bacon pizza, no pineapple, and we don't have any bacon, real bacon, or I would put it on one side. So I will be consuming Canadian bacon pizza, and as always, oh no, I don't have a number. I will be eating it with chopsticks. So get your chopsticks and your Canadian bacon pizza ready, and that's what we'll have. So that's what I have for today. Until 3 hours from now. Make sure you like and subscribe and share this around and click the bell and all that good stuff. And we will catch you again in 3 hours. Bye, everybody.